Okay. Yeah, this is about series, and this time we're going to look at the series as a whole. So let's start from what a series implies. This is simply something. Let's call this A of R, which is equal to 1, 3, 5, 7, 9, 11 to infinity. These three dots means infinity. What has happened here? What I personally observed, if I were not the one that formed this question, what I observed is that the numbers that I'm getting are all gotten by adding 2 to the preceding number. This is 1, it precedes 3. So adding 2 to 1 gives us 3. Adding 2 to 3 gives us 5. Adding 2 to 5 gives us 7. Adding 2 to 7 gives us 9. Adding 2 to 9 gives us 11. Like that, like that, like that. So that thing that I'm adding to each and every of the terms to give me the next term is what I call the common difference. It is the common difference. And this only occurs in a type of sequence, which is linear sequence or arithmetic progression. Linear sequence or arithmetic progression. So this is a sequence. It is not a series. Now look at another one. AR equals to 4, 16, 64, 64, 2, 64, 216, 1024, like that, like that, like that, like that. So what I'm observing here is that if I multiply 4 by 4, I'll get 16. 4 by 64, I'll get 4 by 16, I'll get 64. 4 by 64, I'll get 216. Like that, like that. 4 by 216. Is it 1024? Yes. So I'll get 1024. Like that, like that, like that. So that what I'm trying to say here is that there is something common here too. I'm multiplying each term by something. What is that? It is 4. So that one is not common difference since I'm multiplying. I'm not adding this time. Here I added. Here I'm multiplying. So that is the common ratio. R, and it is 4 here. So now my sequence might be like this and it might be like this. Wherever the sequence exists this way, AR is equal to 1 having the comma sign replaced by a sum sign. So this is plus 3 plus 5 plus 7 plus 9 plus 11 plus to infinity. Whenever I have something like this, 4 plus 16 plus 64 plus 216 plus 1024 plus up to infinity. This is telling me that I'm replacing the commas there with plus sign. So in this case, I have sequences here. This is known as a linear sequence, right? Because of the addition. This one is known as an exponential sequence or geometric progression because it is multiplication. As for this now, it is not even series. It's not even sequence at all. Because of the plus signs there, I'm going to call this series. So this is what we mean by series. Series is formed by a particular pattern or a particular formula that these things follow and they are all added together. That is series. So in mathematics, whenever you see something like this, it is known as sum. It is a Greek alphabet though, capital letter of sigma. This is capital letter sigma and this is the small letter of sigma. So this is capital letter sigma and we call it summation. Summation means addition, sum. We call it summation. Now if I have summation of AR, where R ranges from 1 to infinity, what am I going to write? That means I'm going to write A1. I'll be representing the R with 1 plus A2 plus A3 up to infinity, right?